before we delve into the announcement, it's essential to first grasp what particle accelerators truly are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets, the largest and most powerful particle accelerator ever built. It's not just a feat of engineering. It's a symbol of humanity's scientific ambition. So powerful is this machine that it can recreate the very conditions that existed moments after the birth of the universe. But could this technological marvel, created to uncover the universe's deepest secrets, also harbor something far more ominous? Founded in 1954, CERN stands as one of the world's most prestigious scientific institutions, with 23 member states and thousands of researchers united in pursuit of discovery. The LHC is its crown jewel, yet it's only a part of a larger ecosystem of accelerators and experiments. Think of it not as a racetrack for cars, but for particles, subatomic entities racing at near-light speed through a tunnel that bends time and space. The LHC accelerates protons to just below the speed of light, then slams them together in head-on collisions, mimicking the energy conditions that existed at the moment of the Big Bang. These collisions generate temperatures 1,000,000 times hotter than the sun's core. To control such chaotic energy, thousands of magnets guide the particles precisely, kept at temperatures colder than deep space by sophisticated cryogenic systems. Inside the LHC, these high-energy beams intersect at 4 main collision points, home to 4 immense particle detectors: Atlas, CMS, Alice, and LHCb. Each one functions like a colossal camera, capturing the aftermath of these microscopic collisions in stunning detail. From the data, scientists search for signs of phenomena like the elusive Higgs boson, often dubbed the God particle, and clues about the mysterious substance known as dark matter. By investigating the microcosm, we hope to better understand the macrocosm. Yet every discovery leads to new questions, and every answer unveils deeper mysteries. The LHC is not merely a tool of science. It's a monument of human curiosity and innovation. It symbolizes our unrelenting drive to comprehend the universe's fundamental forces. But as we push the limits of our understanding, we must also confront the ethical and existential dilemmas that emerge. What risks do we take by peering into the unknown? Could our pursuit of knowledge unleash forces we are unprepared to control? Within CERN's walls, where the boundaries of human understanding are constantly redrawn, a chilling revelation has surfaced, sending ripples even through the most seasoned minds. Brian Cox, a former CERN researcher and one of the world's most recognized voices in particle physics, recently made a startling announcement that has both captivated and unsettled the global scientific community. Cox declared with eerie precision that the LHC's ultimate aim is to recreate a miniature version of the Big Bang. Yes, a controlled lab-scale replication of the universe's birth. He went on to emphasize the massive potential this experiment holds, from uncovering the secrets of the Higgs boson to unlocking the mysteries of dark matter, which comprises much of the unseen universe. Imagine possessing the power of creation, the ability to conjure the very essence of existence itself. It's a breathtaking idea, but one that carries tremendous risk. The mini Big Bang is no longer just a theory. It's happening within the LHC. The energy, the pressure, the searing heat, all match the conditions of the universe's earliest moments. It's as if we are standing at the threshold of time, watching the cosmos being born again. But such immense power demands responsibility. What if something goes wrong? History already offers a sobering reminder. In 1978, Russian physicist Anatoly Vygotsky endured a horrific accident while working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia. Due to a malfunction, his head was struck by a high-energy proton beam. The beam entered the back of his skull and exited through his nose, a level of force almost unimaginable. Vygotsky's experience would become one of the most chilling examples of what can happen when particle physics goes awry. It was otherworldly. He saw a blinding flash, brighter than 1,000 suns, yet felt no pain. The beam carved a path of destruction through flesh and bone, leaving behind scorched tissue. Remarkably, he remained conscious, even walking to the clinic for treatment. The aftermath was both terrifying and extraordinary. Localized tissue death, hearing loss in one ear, and partial facial paralysis. And yet, against all odds, Anatoly Vygotsky's intellect remained intact. He continued his scientific career, a living testament to survival, and a chilling reminder of the raw power of particle accelerators. This wasn't just a tragic anomaly. It was a warning, a stark illustration of the immense forces at play in machines like the Large Hadron Collider, LHC. While designed to explore the universe's deepest secrets, these accelerators also carry risks that are anything but imaginary. Some scientists have voiced concerns about the LHC's potential to trigger events that stretch the boundaries of known physics, including the creation of microscopic black holes. Black holes, those dense, mysterious regions where gravity is so intense that not even light escapes, have fascinated and frightened us for decades. They consume stars, warp space, and lie hidden in the darkest corners of the cosmos. The idea that the LHC might create one, even fleetingly, is both thrilling and unsettling. Could such a black hole grow uncontrollably and devour the Earth from within? CERN scientists insist the scenario is virtually impossible. Any black hole formed would be highly unstable, evaporating in a fraction of a second. Still, the mere possibility has sparked public debate, scientific discourse, and profound sense of awe at the scale of power we now command. To understand how such a phenomenon could occur, we must look at how particle accelerators work. The LHC smashes protons together at nearly the speed of light, unleashing energy so intense that they warp space-time, much like dropping a heavy object onto a stretched trampoline. If the impact is powerful enough, the resulting dent in space-time could theoretically form a black hole. In the quantum realm, where physics often defies common sense, some theories suggest extra dimensions may exist beyond our perception. If true, these hidden dimensions could allow for gravitational interaction strong enough to create a microscopic black hole during high-energy collisions. Even renowned physicists have weighed in on these possibilities. The late Stephen Hawking warned of a scenario in which the Higgs boson, under extreme energy conditions, could become unstable. This could lead to vacuum decay, a catastrophic event that might not only obliterate Earth but ripple across the universe, erasing everything. Sir Martin Rees, Britain's astronomer royal, echoed these concerns in his book on the future, Prospects for Humanity. He discussed the potential risks of advanced experiments like those at CERN, not with sensationalism, but with serious, calculated concern. Among the dangers he explored was vacuum instability, a theoretical chain reaction that could alter the very nature of the universe. Though he assigned only a minuscule probability to such outcomes, he argued that even the slightest chance of cosmic catastrophe should make us pause. The stakes are astronomical. The margin for error is vanishingly small. CERN scientists are not reckless. They've conducted exhaustive safety analyses, run countless simulations, and published detailed risk assessments. Physicist Brian Cox has spoken openly about the importance of responsible scientific exploration. He acknowledges public fears, but reassures that the LHC operates under strict safety protocols and intense scrutiny. Still, the LHC remains a symbol of humanity's ambition and its audacity. As we peer deeper into the mysteries of the universe, we must balance wonder with caution, because when you're bending space-time itself, there is no such thing as a harmless experiment. Handled with the utmost precision, Cox emphasized that the energy levels involved in the experiment are well within the bounds of what Earth naturally encounters. The likelihood of producing a stable black hole, he reassured, is astronomically low. Even in the rare event that one were created, scientists explain it will be minuscule and extremely unstable, disappearing almost instantly in a burst of energy. This process, known as Hawking radiation, was predicted by the legendary physicist Stephen Hawking. Such an occurrence would be less a threat, and more a fleeting marvel, a brief glimpse into the unknown before vanishing. Yet, beyond these scientific probabilities, more speculative ideas have taken hold. Some theorists suggest that the Large Hadron Collider, LHC, could tear open a portal to another universe or dimension. While largely dismissed by mainstream science, the concept has sparked fascination, fear, and even modern folklore. Could we, through our experiments, accidentally tap into forces or realms beyond our comprehension? The notion of inadvertently opening a gateway to another reality, or even to something as sinister as a portal to hell, has been sensationalized in media, further blurring the line between science and speculation. But where did this idea originate, And what does it mean in the broader context of scientific exploration? The theory of parallel dimensions isn't a new one. In fact, it's a fundamental part of string theory, a leading framework in the quest for a unified theory of everything. According to this theory, there could be more than the three familiar dimensions of space, and one at a time. These extra dimensions may be tightly compacted, hidden from our perception, but could potentially be accessed under extreme conditions. Now, picture the LHC as a kind of cosmic key, capable of unlocking doors that have remained sealed since the birth of the universe. When protons collide at unprecedented energies, they might briefly recreate the conditions of the early cosmos, conditions that test the very fabric of reality. It's here that, in the minds of some, the gateway to unknown realms could swing open. Though the chances of this happening are vanishingly small, the concept captivates the imagination. What if the LHC isn't just a tool to decode the universe, but a doorway to dimensions we can't yet fathom? Could these experiments redefine our understanding of existence itself? The world watches with a mix of awe and anxiety as the LHC delves deeper into the mysteries of the universe. Its potential for discovery is immense, but so too is the uncertainty. As we venture into uncharted scientific territory, we must grapple with profound questions. Are we prepared for what we might find? And if we do unlock secrets once thought beyond reach, what will we do with that knowledge? At its core, the LHC stands as a triumph of human intellect and ambition. It offers a promise of groundbreaking revelations, but also reminds us of our responsibility in confronting the unknown. As we peer into the abyss, we may find not just answers, but new, unimaginable questions that could forever alter our perception of reality.